Hi guys, still playing around with this 9.6 volt nickel metal hydride battery pack from the hover glider. I've rigged up a little lead here with a car light on it out of my car, because one of the filaments is already burnt out but the other one still works. So I can use that, if I want, to discharge the battery. And I can also use the lead to intercept the current flow and measure the current. So I put that loop in there for. Put my meter onto the 10 amp setting. See if we blow it up. The meter, that is. So we're currently putting 2.5 amps into that light bulb. Or you see it's dropping away fairly quickly. So I should be able to completely discharge the battery and then see if this charger can put any charge into it. And if that doesn't work, I've also got this 9.6 volt battery charger for a cordless drill. Now that one's meant for cadmium, NiCad batteries, so it's not ideal for doing nickel metal hydride because the charging sequence is completely different. But it should be alright if I actually watch what happens. Right, looks like that's nearly drained. That hasn't got hot at all. Let's put in 1.2 amps through. Still, we'll disconnect that and plug the charger in. Oh, I suppose I could just measure the voltage, see what it actually says. Can't get my leads in. Put it back into the right socket. Right, well, we've discharged it down to 9.8. Well, it didn't beep when I plugged it in. I don't know if you remember, but this charger is supposed to have a beeper on it, which I assume, being as it doesn't beep when I put a flat battery into it, must be when it's fully charged that it beeps. With that lead that I've rigged up, I can go onto the contacts in this charger, the cordless drill charger. If I press the button, that gives us 10.4 volts with no load. So that'll be the next plan. See if we can charge that from that. Now that I've got this light bulb out of the car, I can put some extra load on this charger by going straight across the battery. And you can see doing that, we actually get a red LED to indicate that there's charge going through. So clearly that charger considers that that battery is fully charged and it's not going to put any extra charge into it, so we're wasting our time waiting for it. So now we'll see what we can do with this charger. I've got this set up to the 10 amp setting so we can see what amperage is going in. So that's 0.6 of an amp going into the battery now. The only problem is I've got to keep my finger on this button. That's not very satisfactory. I'll have to rig something up so I can keep it charging, because this charger's got a timer in it. It's the old way of charging batteries, and you press this button and that sets the charger for 1 hour. This is a bit of a lash up now. I've got something there holding that button in for the timer. So we're now putting, according to my meter, 700 milliamps into there, which is rather a lot. So we'll see which goes first, whether the charger overheats or whether the battery overheats. We've only been charging for about 5 minutes. It peaked at about 0.74 amps, and it's now steadily going down again. Probably not my most effective time-lapse video. I forgot that it gets dark at night. I've been in the other room working on my YouTube channel and remembered it's gone dark in here, so I've just come in and switched the lights on. Oh, that's just beginning to get warm. That's the first time I've felt those get warm under charge since I've had it. There's just a little bit of warmth in the charger as well. And it will have been on charge, well, it's about 55 minutes I should think at the moment. So I suppose I could give it another 5 minutes just to make it an even hour. We're still putting 0.58 amps into it, so it's still going in at a fair rate. Do I leave it a bit longer? Being as these are now getting warm, that should mean that they're fully charged. I think I'll assume they're fully charged and give them a try. A quick look, see what the voltage says. Mm, 11.79. Let's try it out. We'll go without the skirt. So what did we do? We certainly didn't get minutes of play there. I think we had about 30 seconds, if that. So I guess now we decide that the battery pack itself is faulty. If we've given it a fairly good charge. Difficult to make a decision. I've given it about an hour's charge at a high rate, whereas in the past we've been giving it 2 or 3 days of charge at a very low rate, and we get about the same out of it. Summary time. What have we learnt? We've learnt that new battery charger isn't putting any charge into the battery. If I put extra load on it, we can see that the LED on the charger turns red. So obviously, because it's green, it thinks that it's fully charged, even though we're not getting much out of it. Lashing up my cordless drill charger to charge it worked, but I think we've now established that that battery pack really isn't holding enough charge to run the hovercraft for any length of time. So do I spend any more money and buy a new battery pack, or do I just use the battery pack I made up myself? Decision time. I don't really want to spend any money on another battery pack, because this thing really needs a skirt to make it go well. I made a temporary plastic skirt the other day. It worked, but I don't know. I don't think it's worth spending any more money on it.